So for most typical functions, right, we have a function. Let's say something like that. Okay, and then we typically analyze this function not infinitely, but in a given interval, like a, let's say, to b. To analyze this, so assuming that, let's say, we don't even know how to draw it, we use the first and second derivative. So what did the first derivative do? The first derivative tells you these points. Right, so at those points, let's call it C and D. They're both going to equal to 0. So what else does first derivative tell you? Okay, the second thing that the first derivative tells you is whether it's going up or down. So if you just had the first derivative, the graph will look like this to you. Straight, up, down, up. That's all you can visualize. Okay, up, down, up. And just by looking at it, we can see that when it goes up and it goes down, it has to be local max, right? And when it goes down and up, it has to be a local minimum. Okay. So what I just described right now is the first derivative test. Okay, so that's what you know from first derivative. Okay, and the second derivative tells you the curvature. Okay, second derivative tells you the curvature, so whether it's concaving up or concaving down. So it's curvature. And here's what we want to do in optimization. Okay, every problem can be turned. Okay, it can be turned into a function, a relationship between the two. So it's not going to be like y will be something and x will be something. It'll be turned into a function. And to find the optimal solution, right, we found that from the extreme value theorem, it's either going to be one of these points. Right? In this particular picture, that's the optimal highest value. Right? Here's the minimal value. But we only need to consider, right, these endpoints and the local max minimum. So step 1 of optimization question is to find this first. Okay, and the step 2, right, will be to do the first derivative and analyze this. And step 3 is to draw conclusions in relation to what the question is actually asking. Okay, so we're going to turn a word problem into a graphing problem. That's what we're trying to do for every question in optimization. I'll tell you this is the hardest part, turning into finding the right function.